Completing the square. So it is very nice when the equation for a parabola is in vertex form, like it is right here, because we can say that the vertex is h comma k. But not all equations come in vertex form, so what we're going to have to do is make them into vertex form. So the way we do that is by completing the square. The key to completing the square is this part right here, this x plus or minus something squared. So we're going to create an x plus or minus something squared in the following for the following trinomials. Now, these are all called trinomial squares. It's a trinomial square because if you square it, it creates a trinomial. So I want to go backwards to see like how this looks. So if my trinomial square was x plus 4 squared, that came from x plus 4 times x plus 4. If you distribute, you can either distribute or do the box, you would get x squared plus 4x plus 4x plus 16, which is, if you combine like terms, x squared plus 8x plus 16. If we look at our other one, x minus 9 squared, that's x minus 9 times x minus 9. So that is x squared minus 9x minus another 9x plus 81, which gets us to x squared minus 18x plus 81. So let's see if there's a pattern here. My original number on this first one was a 4. But my two new numbers, when I distributed and collected like terms, is an 8 and a 16. Well, 8 divided by 2 is 4, and 4 squared is 16. So let's see if we can kind of come up with a very similar pattern on the other one. When we first started, we had a 9. We did have a minus 9. And we got an 18, negative 18, and an 81. So let's see if we can do the same thing. If I took negative 18 and divided it by 2, I get negative 9. Very nice. And if I take negative 9 and square it, I get 81. So those numbers that you end up with when you distribute are completely related to the original factored numbers. So we're going to use that idea to complete the square. In other words, we're missing the constant. We don't have a plus c right here. So here's the steps for completing the square. And you're only going to be given x squared plus bx. What you're trying to find is c. So what you do is you divide b, which is our coefficient of x, by 2, and then you square those results. We kind of saw that back up here. We took b and we divided it by 2, and we took that result and we squared it, and that's the constant here. We took b, we divided it by 2, we squared it, and we got the constant right there. So it is a pattern and we get to use that. So the factored answer, when you get your final factored answer, ends up being x plus or minus, depending on if it's a plus or minus problem, whatever b over 2 was. Because remember up here, when we divided it by 2, this number came from the original problem. So let's see how we can use this. So it says first, divide b by 2. b is always the number in front of x. So on this problem down here, b is 16. So I'm going to go 16 divided by 2, and I'm going to get an 8. Then step 2 says to square that. So 8 squared is 64. So that means that my constant, which belongs right there, is a 64. So I could rewrite this as x squared plus 16x plus 64. Now to get our factored answer, it's going to be a trinomial square. It's got to be, because that's how I created it. And it's an x plus, now let's look what we have here, b divided by 2. Well, when I divided b by 2, I got 8. So I'm going to say x plus 8 squared. Now let's just double check that really quickly. If I were to multiply x plus 8 by x plus 8, I would get x squared, 8x, 8x, and 64. And if I were to add 8x with 8x, I would get 16x. There's my x squared, there's my 64. Yes, I did indeed factor that correctly. So let's try another one. X squared minus 10x plus or minus, I have no idea what. So step 1, take b, which is negative 10, and divide it by 2. That's a negative 5. Step 2, take that result, negative 5, and square it. That's a 25. So that means that my missing constant to create a trinomial square is a plus 25. So if I wanted to write a trinomial square that starts off with x squared minus 10x, I would need plus 25. Now keep in mind, this right here is the key to our factored answer, that b divided by 2, because that makes it x minus 5 squared. So factored is x minus 5 squared. If you remember, factoring a trinomial where x squared is by itself, you might have remembered back in the day in Algebra 1, you're doing a diamond problem and you're trying to find what two numbers multiply to 25 and add to negative 10. That happens to be negative 5 and negative 5, which also gets you that answer right there. Okay, let's try one more. Now I am giving you one that has a fraction for a very specific reason. If you were to divide something by 2, it's the same as multiplying by a half. These are exactly the same thing. So if I take b, which is 6/7, and divide it by 2, I can then instead say multiply by a half. If I cross reduce, I get 3/7. Keep in mind, that's going to be part of our answer most likely. So I am then going to take that result of 3/7 and I'm going to square it. This is not as complicated as it looks. Basically, 3 squared is 9 and 7 squared is 49. So there is the constant that I'm missing to make a trinomial square. So I would have x squared plus 6/7 x plus 9/49. And if I were to factor that, I'm going to have x, remember this is our key for factoring, plus 3/7 squared. So there is our trinomial square, and that is what it is when it is factored. Writing the vertex form of a parabola by completing the square. So we're going to use our completing the squares skills to actually help us eventually graph a parabola. So what we're going to do is we're going to take an equation that is in y equals ax squared plus bx plus c form, and we're going to rewrite it in our vertex form, y equals a parentheses x minus h squared plus k. You'll notice that the only consistent letter in terms of what we'd have a number is an a. Those a's do actually match. The b and c do not end up being there. We end up having to find new ones of h and k. So there are 5 steps. Feel free to pause this at any point in time to write this down, because I highly suggest that you follow these step by step and have them next to you as you're doing your assignment. If you do, as you go through the problems, it'll get quicker and quicker because you're going to get used to the pattern of what you're going to do. So step 1, if a does not equal 1, divide all terms by a. I will explain this more as we get into some of these problems. Step 2, divide the coefficient of x by 2, then square that number. That should sound familiar because this is what we did when we completed the square. There's just a couple of extra steps around it when we're dealing with an entire equation. Step 3, add this answer to the first 2 terms. So the first 2 terms are that x squared plus bx type stuff. And subtract it from the constant. So what you're doing is you're adding it and subtracting it on the same side, giving you a net gain of 0. That makes it so we didn't actually change the equation. You can't just add a number to one side unless you add it to the other or subtract it from that same side. So if you add it and subtract it, like adding 2 and subtracting 2, you've really done nothing, which is fine. That's what we want. So you're going to add it and subtract it. Step 4, the first 3 terms are now your trinomial square. It is x plus whatever the coefficient of x divided by 2 was. So that was this notation up here, that this is what's going to be used in step 4. Whatever the coefficient of x divided by 2 is going to go right there. And you're going to have 2 constants at the end. Just simplify those, combine like terms. Now the last step is only if a didn't equal 1 from step 1. If a doesn't equal 1, then you have a number at the moment with y. You need to multiply both sides by that a value so that y is again isolated. So let's see how this works. Here's our equation, y equals x squared plus 8x minus 6. That is not a trinomial square as it stood. If it was a trinomial square, well then our job would be done. That's awesome. It's not. Step 1, the coefficient of x squared, a, is a 1, so we don't have to worry about step 1. Step 2, take the coefficient of x, which is 8, divide it by 2, that's 4. Take that resulting answer and square it, so that's 16. Again, this is the completing the square section of this work, so this should sound really familiar. Now here's where the new part comes in. I'm going to separate this, our original problem, with a little bit of space. We're going to take this 16 and we're going to add it to the first 2 terms and subtract it from the last 2 terms, the last term. So essentially those 16s aren't there because 16 minus 16 is 0. But what this allows us to do is, for step 3, factor that first part. So remember that this answer right here is actually going to be within our trinomial square, so that's where our 4 comes from. And if we then simplify the last 2, minus 6 minus 16 is minus 22. So this is now in vertex form, which means if I were to graph this, I know that my vertex is at -4, -22. I also know that it's going to resemble my parent function of y equals x squared because a is a 1. But we now have it in vertex form, and we could use our skills on graphing a parabola given vertex form to graph that if we wanted to. We're not for today, but we could. Let's try another one. Y equals 3x squared plus 6x plus 1. Is a 1? No, it's not. We cannot proceed until we divide every single term by whatever a is. So we have y over 3 equals x squared plus 6 divided by 3 is 2x plus 1/3. That 3 needed to move away from where we are right now, and it's just going to be kind of in a placeholder with the y, and we'll bring it back at the end. So the first 2 terms are these ones, x squared plus 2x. I'm going to take the coefficient of x, which is 2, and I'm going to divide it by 2, which is 1. Then I'm going to take that 1 and I'm going to square it, and that equals 1. So that's our step 2. Take the coefficient of x, divide it by 2, take that answer and square it. So I'm going to add 1 to the first 2 terms and the last constant. So I'm just going to kind of separate them there so I can put a +1 and a -1, a net gain of nothing. So our first 3 terms are a trinomial square. Remember, this is our key number here. So we have x plus 1 squared, and 1/3 minus 1 is 2/3. So we're not completely done because y is not isolated. So this is where step 5, we now need to multiply or divide everything by a to get our y by itself. So we're going to multiply every single thing by 3, and we're going to get y equals 3, absolute value of x plus 1 squared, plus, if I make 2/3 times 3 over 1, the 3's cancel, plus 2. Now notice that my 3 that I multiplied by just went in front of the parentheses. I did not multiply the stuff inside of the parentheses. Just put it in front, knowing if we wanted to distribute it, we could. So now I can say that my vertex, if I wanted to know my vertex, is at -1, 2. And this parabola is going to be a very thin parabola opening up Because my slope is a 3. The sides of my parabola are going up 3 times quicker than the original y equals x squared parabola. Okay, let's try this one more time. Y equals 5x squared plus 3x minus 1. So our coefficient of x squared is not a 1. I'm going to divide every single term by 5. This is step 1. Divide every single term by a. I have y over 5 equals x squared plus 3/5 x minus 1/5. Now I'm going to take my coefficient of x squared, which is 3/5, and I'm going to divide it by 2. Remember what we said in the completing the squares. Dividing by 2 and multiplying by 1/2 are the same thing. So I'm actually going to multiply it by 1/2 because it just makes it easier for my fractions. So that would be 3/10. Multiply numerators, multiply denominators. Then I'm going to take my 3/10 and I'm going to square it. 3 times 3 is 9. 10 times 10 is 100. So this is the number that I'm going to add and subtract to my different terms. So first I'm going to add 9/10 to the first 2 terms, and I'm going to subtract 9/10 from my constant, a net gain of 0. And don't forget, when you've divided the coefficient of x by 2, that's the key to your factoring answer. You can do less work if you remember that that's your key. So if I want to factor my first 3 terms as a trinomial, that 3/10 is what we're going to use. So 3/10 squared. I still have a y over 5. Now, negative 1/5 minus 9/10. If we're going to subtract fractions, and they're both fractions, we need a common denominator. I can multiply 5 by 2 to make it a 10, so I'm going to. That makes it a negative 2/10 minus 9/10, which is common denominator 10, negative 2 minus 9 is negative 11. So I have minus 11/10. And my last step, my y needs to be by itself. I'm going to multiply every single thing by 5, the y by 5, the parentheses by 5, and my constant by 5, or 5 over 1. That's gone. I have 5 parentheses x plus 3/10 squared. If I reduce, I get a 1 and a 2, so minus 11/2. And I can now say that the vertex of my parabola is at 3/10, comma, negative 11/2. And I know this is going to be a very steep parabola because my sides are being multiplied by 5. And it opens up.